Now we're going to take a look at solving absolute value equations. You should remember from earlier classes that absolute value is the distance a number is from 0. So if we look at -3, it's really easy to see that it's a distance of 3 from 0. And the absolute value of 3 is also a distance of 3 from 0, just in the opposite direction. So we see the absolute value of -3 is 3, the absolute value of 3 is 3. Pretty simple. That's the symbol for absolute value. So now let's just do an evaluation problem. Here we have 3 plus the absolute value of 5x minus 12, and we're going to evaluate that if x equals 2. So we will substitute, just like we did in earlier sections. We're going to substitute the 2 in place for the x. So we get 3 plus absolute value of 5 times 2 minus 12. The absolute value acts like parentheses, so we have to evaluate this portion first when we follow order of operations. 5 times 2 is 10, so I'll just put a 10 here. So I have 3 plus the absolute value of 10 minus 12. Well, 10 minus 12 is -2, so I get 3 plus the absolute value of -2. Then I need to evaluate the absolute value of -2, which would be 2, because it's a distance of 2 from 0. So this becomes 3 plus 2, which is 5. Let's take a look at the same problem, except now we'll let x equal -3. So we have 3 plus the absolute value of 5 times -3 minus 12. Evaluating here, we get a -15. 5 times -3. So now we have -15 minus 12. You might want to change this to adding the opposite. It's your preference if you prefer to think of it that way. So I have 3 plus -15 plus -12 is -27. The absolute value of -27 is +27, so 3 plus 27 is 30. So evaluation problems shouldn't be too hard for you. You are substituting those values in. Here's an equation we need to solve, an absolute value equation. So here we're asked to find, we have to solve for y, the absolute value of y equals 12. So this is the question you need to think about. This is saying, what number is a distance of 12 units from 0? Well, it could be this 12 units this direction, which would put us at 12, or it could be a distance of 12 in the opposite direction, which would put us at -12. So actually, there are two answers. Y equals -12, or y equals 12. And that's going to be quite common when we have absolute value equations. You will often, but not always, have two solutions. Let's take a look at a little more complicated problem. Solve the absolute value of x minus 7 equals 12. Well, think of it this way. This is really saying the distance between some number and 7 is 12. So I need to be a distance of 12 from my number 7. So it could be a distance of 12 in this direction. And if the distance was 12, that puts me at 19. Or it could be a distance of 12 in this direction, which puts me at -5. So I get two answers. Okay, the reason this first solution to get the 19 really is x minus 7. X ends up being 19. And this one over here ends up, because we're talking about the difference between the two numbers. And so we switch that around and we have 7 minus x instead, because we're going the opposite direction. So we end up with our two solutions. So we have x equals -5 and x equals 19. Now, You probably don't always want to draw a number line, so I'm going to show you how you can work the problem out to get both solutions. For the first solution, so we're going to have two cases. To get the first case, you're just going to drop the absolute value, and this is the one that everybody gets. To get the second case, we're going to drop the absolute value, and we're going to change this other side of the equation to the opposite. Kind of signifies that we're going the opposite direction on the number line. So now we just solve the equation. So we're going to here subtract 12. So we get A equals 21. And here we also subtract 12. And we get A equals negative 45. Now with absolute value equations, you always want to get in the habit of checking your answers. So if you substitute a 21 in for A, 21 plus 12 is 33. The absolute value of 33 is 33. Substitute a negative 45 in for A. Negative 45 plus 12 is negative 33. The absolute value of negative 33 is 33. So both of my solutions work. For the next problem, what makes this a little different is I have this plus 5 here. So the first thing you're going to need to remember to do is isolate the absolute value. So we need to isolate that portion. So the first thing I'm going to do is subtract 5 from both sides. And I get the absolute value of 6 minus 4t equals negative 5. Now I want you to stop and think about this for a minute. Remember that absolute value is a distance. So this is saying some distance between two values is negative 5. That should bother you because you can't have a distance that's negative. And when you end up with this situation, you're going to have no solution. Now suppose you didn't notice that and you just decided to solve the problem the way I showed you. You would have your two cases. So the first case, you would have 6 minus 4t equals negative 5. And your second case, you would have 6 minus 4t equals the opposite of that. So then we'll solve. We'll subtract 6 from both sides. And divide both sides by negative 4, which gives me 11/4. Let's try this side. Subtract 6 from both sides. I have negative 4t equals negative 1. When I divide by negative 4, I'll get a positive 1/4. So now let's check our answers. Don't let it bother you that they're fractions, because when you substitute in an 11/4, the 4's will cancel and you'll have 11. So 6 minus 11 is negative 5. The absolute value of negative 5 is 5. And 5 plus 5 is definitely not 0, because we get 10. So that solution doesn't work. Plug in a 1/4. Up here, the 4's cancel. You'll be left with a 1. 6 minus 1 is 5. The absolute value of 5 is 5. Plus 5, again, is 10. This solution doesn't work. So I'd still come up with no solution. However, if you didn't check your answers, you'd have 2 wrong answers, and you might go on and think you did the problem correctly. So you can avoid all of this work if you recognize this portion here. If you recognize that you can't have an absolute value end up being a negative, then you can stop there and say it's no solution. One more problem to try. Now the absolute value is already isolated, but you might notice that we have a negative on, or I'm sorry, we have a y, a variable, on the right-hand side as well. You're still going to have 2 cases. So we'll have 8 plus y equals 2y minus 3. And then for the other direction on the number line, we have the opposite of 2y minus 3. Be very careful here. You have to do the opposite of the whole quantities, which means you're going to have to distribute a negative sign. We want to combine like terms, so I am going to subtract y from both sides and add 3 to both sides. So I have y equals 11 for one of my solutions. On this side, I'm going to distribute the negative sign, like having a negative 1 times 2y and a negative 1 times a minus 3. So I get plus 3. I'm going to add 2y to both sides and subtract 8 from both sides. So I get y equals negative 5/3. Now, just because you get a negative answer does not mean it's not a solution. Okay, you can sometimes have variables that will be a negative answer, but we still have to check because it might not be. So let's start with the 11. Substitute the 11 in. I get 8 plus 11, absolute value of that, and I want to see if these two quantities are equal if I plug it into both sides. Here I get 19. The absolute value of 19 is 19. 22 minus 3 is 19, so we're good on this solution. Negative 5/3. If I plug in a negative 5/3 plus 8, I'm taking the absolute value, so I know I'm going to get a positive value on this side. If I plug in a negative 5/3 over here, I'm not even going to work it out, because I know that if I multiply negative 5/3 times 2, I'm going to get something negative. And if I subtract 3, it's even going to be more negative. So I'm going to have something positive on the left side, and I'm going to have something negative, I ran out of room, on the right side, and that can't be equal. So even without doing the math, I can tell this solution won't work.